Hey everybody, I wanted to do a couple more examples on determining if a subset is a subspace of a vector space. So let's take a look at this example. So we want to determine if this subset is a subspace of R4. The subset is the set of all vectors of the form A, B, C, D, where A and B are both 0. So the first and second entry are both 0. Now before we go anywhere, what we want to do is we want to decide, do we think it is a subspace? What we need to check, or what we should check in our minds, is if we add two vectors, do we expect it to lie outside of the subset? Or if we multiply by a scalar, will that lie outside of the subset? So in this case, we can ask ourselves, if I have two vectors where the first and second entry in each vector are both 0, when I add them, what will I have? Well, if the first entry is 0 in both of them, then 0 plus 0 is still 0. And the second entry being 0 in both of them, then the sum would still be 0. So the first and second entry of the sum of the two vectors is still 0. So we should expect that the sum belongs in the subset. Now, for a scalar multiple, we say, okay, let's take a vector where the first two entries are 0 and multiply by a number. Okay, well, 0 times anything is still 0, so the first and second entry are still 0. So we anticipate that this should be closed under scalar multiplication and vector addition. So we want to say that this will be a subspace. So now we should show that. If you don't know immediately or don't have a good idea, it may take some side work where you need to take a separate sheet of paper to decide whether you anticipate it being a subspace or not. The work that you present and that you hand in should justify your conclusion. If you're unsure of your conclusion, you should do some additional work before you prepare the answer you're going to submit. All right, so we've decided that we believe it will be a subspace. So let's let U be equal to 0, 0, U3, U4, and V be equal to 0, 0, V3, V4. And both of those are in W since the first and second entry are both 0. We should also let C be some real number. Alright, so we want to check closure under addition. U plus V is equal to 0, 0, U3, U4 plus 0, 0, V3, V4. And this is going to be equal to 0, 0 plus 0, 0, 0, 0 plus 0, 0, U3 plus, V3, and U4 plus V4. And clearly this is in the subset. So W is closed under addition. Now we also want to check scalar multiplication. So closure under scalar multiplication. So we want to see if C times the vector U is still in W. So C times U is C times 0, 0, U3, U4, which is C times 0 is 0, C times 0 is 0, C times U3 is CU3, and C times U4 is CU4. Right? And again, the first and second entry are still 0, so this belongs in the subset W. So we have that W is closed under scalar multiplication. Excellent. So it's closed under addition, closed under scalar multiplication. Therefore, W is a subspace of R4. And that's what we were looking to show. If you have any questions, please let me know.